next part is a transmitter. See, when we say ki we are having controller, we have to control the process. This is a process area, correct? Na? In this process area, we have completely defined the loop. When the process is there, the first part is the sensor should be there. The parameter which you want to maintain, you have to sense it first. Maybe it is temperature, level, pressure, flow. Whatever may be the parameter which you want to maintain, you have to sense it first. So for that purpose, the sensors are there. Then the signal is given from the sensor to the controller. In between that, definitely something will be there that we are going to discuss. Okay, the signal is given to the controller, and then controller will decide, okay, this is my set point and this is my process value which I am getting. Okay, now what type of action I have to take so that the process value which I am getting, it is supposed to be moved towards the set point. Deviations होता है, deviation ला मी कमी करतो. Correct? So here the controller is going to take action on the control ball. Maybe this control wall is to control the steam so that we can maintain the temperature. Maybe this control wall is going to control the flow of a liquid so that the level it is get maintained. Maybe this control wall is going to control the flow so that the pressure it is get maintained. So for the different parameters, normally we are using control wall to control the flow. Correct. So these are the things which are supposed to be there when we want to control any process. But remember one thing, this controller is present in a control room, and these sensors and valves are present in a plant. We can say it is in a process side. Correct. This is my process side. It is in a plant, and this is in a control room. So we have to transfer this signal from sensor to controller. The process signal which you sense, suppose we sense the temperature, and the temperature range is 20 degrees centigrade to 120 degrees centigrade. This is my temperature range which I have defined. Maybe for different processes, different pressure temperature range will be there. Your simple process is there in which your temperature will not go above 120 degrees centigrade and it will not go below 20 degrees centigrade. As the process I thought, definitely I have to define that range. But in some processes, maybe the temperature varies from 0 degrees centigrade to 1000 degrees centigrade. So your temperature range should be different. And for that temperature range, you have to define the different type of sensor. As we have discussed in the sensors part, yes, RTDs and thermocouples, normally we go for 120 degrees centigrade. RTDs normally we go for 120 degrees centigrade or 200 degrees centigrade, correct? Na? But if suppose we say the temperature is 800 degrees centigrade, we will not use the RTD. We will go for the thermocouple, but again it is not for J and K, correct? Normally S and T's are used for the higher temperature measurement, correct? So the first thing which you have to define, the sensor which is going to sense the process parameter, it is having some range. It is having some range. This is the first part that you have to define. Okay. When I define that my temperature will not go below the 20 degrees centigrade and will not go above the 120 degrees centigrade. So that is my temperature range which I will select. But this temperature, it is supposed to be transmitted from the plant to the control room. So for that purpose, we must have something. This is the first part. Second, when the controller will take action, what this control wall is having range. Kitna? Fully closed to fully open, correct? Na? In between that it is having, we normally say 0% and 100%. When controller is going to decide, I want the 0% opening of the control wall, some signal it is supposed to be sent. I want the 50% of the opening of a control wall. Controller is going to decide. So it is supposed to send the signal. I want the 100% opening of a control wall. So that range I have to define. So what should be the signal which I have to transmit from the again control room to the plant? Normally the signals are traveling from plant to control room and from control room to plant. This is the important thing that you have to remember. In my control room, when I sit, I have to remember one thing. Definitely there are some signals which I am getting from the field, which I am getting from the plant. Yes, and I have to transmit some signals from the control room to the plant or to the process, to the field. Is it correct? So these things you have to remember first. Okay, next, Next, there is a very important word, and that is a transmitter. What is the function of transmitter? To transmit the signal. Very good, very correct answer. The simple function of a transmitter is to transmit the signal from one location to another location. Correct? Our two different locations are there: plant and control room, process and control room, field and control room. These are the different words normally we use. Okay. Now, for measurement of a system or control system, when you define that, we have to measure something and we have to control something. These are the two different things. There are some parameters which we are not going to control, but we are going to measure them. बऱ्याच वेळेस असे पॅरामीटर असतात की मी त्यांना फक्त मेजर करतो, मी त्यांना कंट्रोल करत नाही. बट देर आर सम पॅरामीटर्स फॉर विच वी मेजर देम and we control them. So in that thing, the first thing you have to define the specification point of view, that is my range, which I have already explained. When I sense a temperature, when I sense a pressure, when I sense a level, okay, maybe it is from 0 to 100 mm or 100 cm or 1 meter, we can say. There is a one tank, I am going to maintain the level from 0 to 1 meter, 1000 mm, correct? But there is another tank, maybe you are having 0 mm to 5000 mm, 5 meter. So you have to define your range first, and that is very important part. When you go into a process, you have to define this thing. So part of the specification is the range of the variables involved. If a system is to measure temperature, there will be a range of a temperature specified. Normally we say, for example, it is 20 degrees centigrade to 120 degrees centigrade. Now this, I am not going to transfer the degree centigrade directly, or I am not going to transfer the heat into the control panel, correct na? Process parameter get converted into electrical form. It is by sensors and transducers. That is the two units which two subjects which we have studied. Correct. Process parameters get converted into electrical form. Okay, I got the electrical signal, but I have to define a range. मला कुठे पाहिजे? Okay, I use the RTD. I use a thermocouple. So as you know about the RTD, 0 degree PT100, 0 degree centigrade, 0 degree centigrade, किती resistance? It is 100 ohm. Very good, very correct. 10 degree centigrade, 10 degree centigrade, 103.9, 103.9. 1 degree centigrade increase झाला की 0.39 ohm हा increase होतो, it is get added, correct na? Then 20, 30, 40, for every temperature we are having some resistance. That resistance you have to maintain, but that resistance we are not going to transfer to the control room. What type of signal you are going to transmit? We generally prefer the current. That we will discuss in detail. Why we go for the current? Why we will go for the current? That we will discuss. But here we got change in resistance from the RTD. Then it is get converted into current form. So what should be the current form range? Now, if my range is from only 20 degrees centigrade to 120 degrees centigrade, I will get the resistance range, and that resistance range, it is get converted into 4 to 20 milliamp. My 20 milliamp is now going to define 120 degrees centigrade, and 20 degrees centigrade is going to represented by 4 milliamp. Maybe there is another process in which I am going to measure the temperature 20 degrees centigrade to 200 degrees centigrade. Don't consider always कि 4 milliamp means it is 20 degrees centigrade and 20 milliamps means it is 120 degrees centigrade. You have to define. You have to define. Okay, maybe another process is there. You are having temperature range to 20 degrees centigrade to 200 degrees centigrade. Now I am going to convert it into a current form. In that case, my 4 milliamps is going to represent 20 degrees centigrade and 20 milliamps is going to represent 200 degrees centigrade. This is what we say the specification or the selection of a range. This is called the selection of a range. Is it correct? असं प्रत्येक पॅरामीटर बाबतीत होऊ शकतं, लेवलच्या बाबतीतही होऊ शकतं. The example which I have given, maybe in one example 0 to 1000 mm is going to represent 4 to 20 milliamp. But there is another example, 0 to 5000 mm is going to represent 4 to 20 million. So that is the part. This is one example which is there and which is going to convert it into current form. Okay. If the controller is to output a signal to a continuous valve, as I have already explained, controller wants to open the control valve 0% and 100% in between that. Yes. So what should be the signal which is given by the controller to the control valve? Normally, I2P converters are present in the field. Remember, I2P converters are present in the field. But remember, I2P converters are normally present beside my control valve. Control valve के बाजू में होता है. And then the electrical signal is given from the control room to the I2P converter. And then I2P converter will convert that current form of signal into pneumatic form 3 to 15 psi. Got it? Yes. So this is the example which is given. This signal will be designed to cover the range from the fully closed to fully open with all the various value settings in between. Correct? 4 milliamps when it is given, the control wall is completely closed. It is 0% open. When the 20 milliamps is given, the 100% opening will be there for your control wall. This way the ranges it is get defined. Okay. Next. Evaluation of the control system. In a previous day, normally before 1950, maximum loops are of pneumatically operated. That days, electronic controller and electronic digital controllers are not get evolved. Before the 1950, we are not having digital system. Maybe the inventions are going on in a computer, but still that days in industries we are not using digital controller. खूप कमी इंडस्ट्री मध्ये कदाचित एनालॉग इलेक्ट्रॉनिक कंट्रोलर असते. But before that days we are having only the pneumatic controllers. Yes, I will show you the pneumatic controller when we have some visit. एका इंडस्ट्री मध्ये आहेत तिथे मी तुम्हाला दाखवेल. So this way we are having here the sensor in a plant, we are having here the control valve, and we are having here the pneumatic controller. Pneumatic controller means the controller is completely operated on the air signal. No electronic component is present. We don't require the power supply. अजूनही काही इंडस्ट्रीमध्ये फक्त न्यूमॅटिक सिग्नल किंवा न्यूमॅटिक कंट्रोलरच यूज केले जातात, कारण तिथे एक स्पार्क इथेनॉल प्लांट, कोजनरेशन प्लांट जिथे प्रोडक्शन होतं त्या ठिकाणी तुम्हाला एक स्पार्क चालत नाही, कारण एन्व्हायरमेंट कम्प्लिटली इट इज व्हॉट वी से गॅसियस फॉर्म मध्ये असतं की जिथे एक स्पार्क जरी झाला तरी पूर्ण प्लांटला प्रॉब्लेम येऊ शकतो. सो दे आर गोइंग टू प्रिफर द न्यूमॅटिक कंट्रोलर. जस्ट वी ट्रान्समिट द एअर आणि त्या पूर्ण एअरवर ते कंट्रोलर काम करतात. नेक्स्ट, need of a transmitter. This is a very simple thing. Why we require the transmitters? Because we have to transfer the signal from the field to the control room, and the signal which is given by the controller to the control valve. As I told you, there are definitely the signals, some signals get transmitted from the field to the control room and some signals get transmitted from the control room to the field. So for that transmission purpose, we must have the transmitters. Otherwise it is not possible. Yes. Evaluation of the control system. Then we got the electronic controller. Evaluation हळूहळू होत गेलं. सुरुवातीचे मोबाईल एवढ्या मोठ्या साईजचे, फक्त बोलता यायचं, बाकी काहीच व्हायचं नाही. नंतर ब्लॅक अँड व्हाईट छोट्या साईज मध्ये आले, त्याच्यात मग रिंगटोन चेंज करता येत होते. त्याच्यानंतर मग थोडे कॉर्बी वगैरे असे आले. अँड्रॉइड नव्हते, कलर मोबाईल आले. त्याच्यानंतर आता अँड्रॉइड आले. पुढचे अजून बरेच आले, माझ्यापेक्षा तुम्हाला जास्त चांगलं नाही. दिस इज व्हॉट वी कॉल्ड इट एज इव्होल्युशन. सेम वे कालपर्यंत प्रोसेस कंट्रोल काहीच नव्हतं ना, आज एकदम सगळ्या प्रोसेस व्यवस्थित कंट्रोल व्हायला लागले असं होत नाही. डे बाय डे इट इज सपोज टू बी इव्हॉल्व. When the electronic controllers are there, definitely the in between things are supposed to be get changed. मग त्या पण चेंज झाल्या असतील. Yes. So what is there inside? या दोघांच्या मध्ये काय? It is a transmitter. It is the role of a transmitter. Two analog standards are in common use as means of representing the range of variables in a control system. Normally दोन टाइपच्या ranges use होतात. The first range is going to represent pneumatic signal and the second range is going to represent electrical signal or electronic signal. ठीक है? The first range is, that is, for electrical systems we use a range of electric current carried in the wires. Maybe somebody say why not voltage? That part we will discuss in detail in the next slides. But here normally we are going to transfer the signal in the current form. Remember, When the transmitter is there, the output of a transmitter, it is in a current form. It is in a current form. And the second range is pneumatic signal, which is we are having some gaseous pressure. Gaseous pressure आपण म्हणायला फक्त gaseous pressure म्हणतो, but the low cost solution is my air. सगळ्यात बेस्ट एक्झाम्पल इज एअर. एअरला आपण प्रेशराइज करतो आणि न्यूमॅटिक सिग्नल त्याचा यूज करतो. येस, नेक्स्ट वन. These signals are used primarily to transmit the variable information over some distance, such as to and from the control room and the plant. These signals are used to transmit the signal from the plant to the control room and from the control room to the plant. Next, connection between the plant and the process. Yes, this type of normally connection. This is my plant side. This is my control room side. Okay, when the sensor sends the signal, the sensor to the current converter type of converters are there. We got here the current signal, and that current signal normally it is in a 4 to 20 milliamp. Yes, and here if we consider the pneumatic signal is a 3 to 15 psi. Remember, it is a 3 to 15 psi. When 3 psi is given to the control valve, the valve is completely closed. Yes, when you go on increasing the pressure above the 3 psi, it start to open, and up to 15 psi, the valve is completely open. The valve is completely open. So the actuator is there, and which is going to control this valve. Okay. Here in this figure, what is shown? When the pneumatic type of systems are there, controller is pneumatic, and then the pneumatic signal is given, and the actuator is there, and the controller valve is supposed to be operated. But nowadays, when we go for this, the electrical signal, it is in a 4 to 20 milliamp is given. Here in the field, we are having which converter? I to P converter. The I to P converter will be there. Electrical signal get converted into pneumatic form 3 to 15 psi, and that 3 to 15 psi signal is going to operate the actuator so that the control valve it is get operated. But here in my control room, generally we deal with the 0 to 5 volt or 1 to 5 volt. Correct? So when we got the signal in current form from the field, it is supposed to be converted into voltage form. I'm normally in my controllers, in my control strategies where I have implemented it. Yes, I deal with the voltage. Output of my controller is normally voltage. Yes, so when I got a signal in current form, it should be converted into current to voltage form. Yes, and here when the output of a controller it is in a voltage form, I have to transmit it. So voltage to pneumatic signal it is supposed to be, it is not normally what I say voltage get converted into current form, and current form of signal that is given here, then we are having here I to P converter, and then the actuator it is get actuated.